Hi, my name is Henslow, and I'm going to be presenting today on my techniques for using Gemini and Jules. And let me just jump into my slide deck. All right. So, general idea here is that we're moving away. So, I know that everybody has like their own kind of way of, um, of using generative AI. One I've been leaning towards recently has been more of a Gemini Jules loop. Gemini and Jules are both Google products. I pay about $20 a month for unlimited access. There is rate limiting, but I don't really ever hit it very often. So there are some problems coming up with a rate limiting as kind of like the biggest differentiator. But I'd rather take rate limiting over a surprise bill at the end of the month. So the general idea here is that one of the things I'm trying to avoid with the technique that I'm using is less one-shot prompt engineering for getting it all done in one prompt, and this is more of a generative, iterative approach. So my technique mainly involves creating a initial prompt and then working through the problem with Gemini to kind of architect the overall problem space, ideate, and then decide whether or not it's worth going into a larger project. And then what I'll do is I'll use Jules, which has backend support with GitHub, to create a project Git repo, and then that keeps and that kind of access the backend database for all the future interactions. I try to keep as much of the discovery inside the repository as possible. It both keeps the Jules on track and also keeps and avoids some of the problems I've had with Gemini, Gemini spinning its wheels and not getting in place. I still use Gemini when Jules gets stuck. Primarily what happens is that Gemini does a better job of green, clear field or green field problem solving. And so what you'll do is you'll take like a one-shot prompt and throw it at Gemini. In rare cases, I'll then do the same thing with OpenAI or some of the other models, and then do A/B testing on the results. And sometimes I'll just feed the results from one agent into the next and kind of create like a cascading waterfall effect. And usually that's because what happens is that either we run into a domain that Gemini doesn't have any expertise in, or its data is out of sync with the latest repo changes. So, for example, documentation normally gets pulled in semi-regularly, and so if whatever project you're working on has had a major documentation shift, feeding that documentation in can be really useful for getting the best out of your agents. So this is going to be a quick case study. So I, like a lot of us, somebody asked me to make a web page. In years past, I would avoid this because I'm not a web developer. But with the power of generative AI, I can now make AI do it for me. So where this kind of comes into play is that the nice thing about this is that this allows me to keep all the web developer tasks like isolated, and that I can keep the ideation and iteration in place. So primarily what I'm doing is I'm acting as the tastemaker for the agent and telling it what I want it to look like, what kind of content, and kind of orchestrate and architect between the customer and the agent to make sure that everything is aligned properly. And then I'm also on the hook for final validation and verification, also the implementation details. So how to get it up on the web, how to set up your your domain name configurations and all that. So generally, this is just kind of like a quick overview of what that would look like in practice. So this was I think one of the first runs I did of this. So um, generally, what we're doing here is we're kind of, after I kind of get through the process of making it easier to see, we're adding in this, my specs were basically 3 documents. They wanted those to turn into a website. So I took those 3 documents. I thought they wanted it set up as with a doc previewer and viewer, so that the customer could download those company documents off the website as part of their basic website. But they ended up not liking that feature, which I'll show later actually worked out nicely, because instead of having to like spend a lot of time working on a feature that nobody cares about, I could just make AI iterate on the idea, and then the customer could say, hey, I don't like that, and I can then tell AI to rip that out, and there's no like loss of time on my part except for the prompt engineering aspect of it. So you can kind of see here, like right now, I run into this a couple times where you have to say continue a couple times when it freezes. Sometimes that's because the task is too big and it has internal timeouts, or the task isn't well defined and it kind of needs some more time to kind of chew on it. There it goes. This is what the actual website looks like. And this is kind of a little bit more about like just the process. So this is I had an agent kind of go over I actually had a bug where the document viewer wouldn't view, and so I basically threw the whole thing at Gemini to take a look at it. It came up with a overview and then some suggestions, and then I used that to get past this. Yeah, so you can see here it's supposed to, when you click on these documents, it's supposed to actually come up. So what I did is I basically just had an error, copied the error over, and then jumped back into Gemini, pasted it in, and like a lot of us, it just kind of goes through and iterates on that. And then I'll take this after it gets done, and then dump this whole thing into Jules, and then have it implement it. So one thing I'd like to bring up is that right at this point, no code has hit my personal computer. This is purely running in the cloud, and it's purely running without me setting up a virtual machine or a web server or anything like that. Jules actually has an internal VM that will spin up for while it's running. So all the iteration and ideation is internal to Jules. And then GitHub static pages allows you to host a static web page off of GitHub pages, and that's what I'm using for the deployment for that. And this is the final video I have on this topic. This is actually where the customer came back and said, I don't really want that JavaScript document viewer that you put together, and please get rid of it. So I just clicked some buttons, asked it to get rid of it. Notice that it also correctly deleted the docx files, and then happy customers and all that. And this is just kind of an overview of just the final um, way of kind of how to do things. So for example, you can kind of see here that like I'm not running just one prompt at a time. I'm actually running like maybe 5 jobs right now. And so each one of them I'm kind of have them queued up. And so from a user standpoint, I'm basically jumping from project to project to project. And for me, it works really well. One of the other projects I've been working on, where I finished recently, was a badge for B-Sides. B-Sides is a security conference that they ran last Friday in Tulsa, and I produced the badge for that. And while putting the badge together, I used generative AI for developing the firmware for the badge. The benefit of this was that it allowed me to basically kind of quickly iterate on ideas, and then also gave me a sounding board to troubleshoot problems with the firmware, and also overcome issues that crop up naturally while doing development like this. Here you can see like kind of a sample of 2 different prompts. One of these was on the left-hand side is the as a prompt for when I was measuring the battery volt or performance of the device. And then I was trying to get some ideas on like what I can do to quiet it down. I've got some ideas on like what it would look like, what it should look like. And then this is just then what it does is it kind of gives me a firmware that I can basically then dump into a single page C++ platform I/O interface for building the project and then loading it on a physical device. On the right-hand side is the initial prompt for this project, or in this part of the project. This was me trying to get a better feel for the battery life issue I was running into. So the initial iteration of this project, the battery didn't last very long, and so I needed some techniques for improving battery life. And so it took a little while to get done, but I probably had to like really do some A/B testing on figuring out whether or not this was faster than just doing it by hand. I can definitely tell you it saved time in reading through manuals, although whether or not this would have been faster than doing it right the first time, it's arguable. It does help with keeping on track with like continued development though. And in a future iteration, there's a use case where you can actually tie in the embedded JTAG tools for actually doing continual development on the hardware itself, so that the agent itself can view the results of your code, and so it would have like a first row seat for continual development, kind of how we see currently with continual development with like web pages and web design, where an agent can look at the results, process the results from using Playwright or other like end-to-end testing or unit testing, and then it can iterate on those results to get you a solid design. My last case study is one that's kind of fun. So I'm a big like TTRPG, tabletop RPG game fan. One of my favorite ones is Shadowrun. And so a couple of years ago, I did a custom campaign and did all the like ideation, running that, and then for whatever reason, time constraints mostly, I couldn't get a group to play with me and play the campaign with me. So what I did is I had an LLM agent run through the campaign from top to bottom, and I used that to create a narrative storybook. And so it did a really interesting job of fleshing out the story and the storyline. And then I had like a campaign book that was better fleshed out. And then we wanted to do some house rule changes, and so I decided to throw the latest generation of LLMs at it to see what it could do. And so then I generated like a full-on like rule simulator, custom rules. I actually used LaTeX or LaTeX to make a end-to-end PDF of the custom house rule set, and then also created a visualizer for running the whole campaign. So the so the other cool thing was that like you can actually one of the nice things about this is that it allows you to in creating a simulation for the rules, it does two things. One, it lets me like run the numbers on like how effective the rules are and like what the results of the rules are, and then also allows me to then do like a one button simulation for the results of the rules. So for example, instead of having to run through combat, you could literally just say, hero stats, here's the enemies, run combat numbers, and then instead of stopping the role playing, you can jump right into the consequences. And then if you want to play it again for real, you can do that as well. And this is just an example of like what that kind of looks like in terms of adding features. This was when in doing this presentation, I realized that I should add a UI UX, and then I actually took the slideshow or a slide from that presentation and added that into this to have it then create a UI UX from it. So one of the things to keep in mind is that like generative AI agents, the way I'm using them currently is a very iterative process. Everything kind of builds on itself. So that's all I have for today. Hopefully this makes it in time to be useful, and thank you for listening. And I think if we get the chance, we'll do questions either remotely or in virtually. And you can find me on Techlahoma Slack as well as on the internet. Thank you. Bye.